consider this given problem statement. So it says that in the triangle ABC, let the length of this AB, so AB is the side and the length of AB is given square root of 23. Then length of BC is given as 3. So since the unit is not given, so we'll assume the standard unit of length, let's say. And the length of C is given as 4 units. So in that case, we need to compute the value of cotangent of A plus cotangent of C over cotangent of B, right? So first of all, we need to observe the given data, right? So we know the rule of sine, which says that the side length A over sine of angle A, it is equal to the side having length B, the ratio of this side length B and sine of angle B, this is equal to C over sine of angle C. So this is what the sine rule states. Now in the problem statement, it's clearly mentioned that it's given that it is a triangle ABC, right? So if it is a triangle, so the property of triangle says that sum of three angles will be equal to pi radian, and this, from this we can clearly write that A plus C. Why I'm considering A plus C here? Because in the target you can observe it is cotangent of A plus cotangent of C. So that's the reason. And this is equal to pi minus B. Now here, this is the given expression. So we'll be solving this part, right? Now here, I'll just replicate this as it is. Now here, this cotangent, I'll decompose it into sine and cosine. So this cotangent of A can be written as sine A over, so this will be cos A by sine A, right? So cosine of A over sine of A. And similarly, I'll do it for the angle C, and the same for angle B as well. Same for this angle B as well. Cotangent of B would be cosine of B over sine of B. Now after resolving this expression, we can write this one as, so here in the denominator will be having sine of A, then sine of B, no, this would be sine of C, and then cosine of B. And here if you observe, this will be cosine of A times sine C and sine of A times cos C, and that can be compressed as sine A plus C, right? So if you observe here, sine A plus C can be expanded as cos A times sine C plus sine A times cos C, right? This expression can be written, and here sine B will be multiplied over here. Now A plus C is pi minus B, right? So I'll be using this one. Now in the next step, I'll replicate this one, and instead of A plus C, I'll replace it with pi radian minus B. And this one, if I use the identity, so this would remain sine B. So sine B, this would be sine of B as it is. So this is sine squared B, right? And now I can just plug in the values like sine B. So this sine B can be written as, if you can observe these ratios, right, that is sine B over sine A. So sine B over sine A, this can be written as B over A. So if you can just observe this from this one, in the next step, I'll just replicate it here and just mention the reasons one by one. If you observe, so from this we can imply that sine B over sine A. So this one I'll copy it as it is. So sine B over sine A, this is B over A, right? So this can be written as B over A. So sine B over sine A. So this is one thing. Then next again we are having sine B over sine c. So I'll just go to the next step, and these remaining terms I'll keep it same. This one is already computed. Now my focus is on sine b over sine c. I can do it in same step, but still for better clarity I'm just going step by step. Sine b over sine c. So from this one, sine b and sine c is something that is important for us. Now from this we can clearly write this one as sine of c over sine of b. So this can be written as b over c. So this one, sine b over sine c. So this can be written as b over c. B over c. And this 1 by cosine of b, right? So this 1 by cosine of b can be written as 2 times ac over a square plus c square minus b square. So I can write that thing instead of cosine of b. So using the cosine rule, right? So now I'll proceed towards the next step. So for this one, I can write this one as 2 times ac over a square plus c square minus b square using the basic properties. Now I'll just plug in the values. On plugging these values, that is, if you observe this AB, then BC and AC, that is 4. So from this we can write 2 times this AC would be 16. That is the product of 3 and 4, right? 16. And this would be A square. So A square would be 9, and C, that is square root of 23, that will be, if I square the square root of 23, so this will be 9 actually. 3 square is 9, and this will be 23, and here minus 16. On resolving this, I'll be getting my answer is 2. So therefore, for this problem statement, the correct answer is 2, and hence this is the answer.